Welcome to the Cadaviz DICOM viewer tutorial. In this video, we will explore its key features and tools for medical image visualization and analysis. Explore a library of 1,200 plus pathology cases, organized by anatomical region, imaging modality, CT, MRI, ultrasound, and pathology for quick and intuitive navigation. Next, upload your own DICOM study, select the upload icon, choose the required folder, and load it. The study will appear under My Uploads. Next we have anonymization, select Anonymize, choose the study folder, validate it, enter a new patient name, and click Apply. The anonymized study is saved in My Uploads. To explore a sample case, select CT as the modality and open the abdominal aortic aneurysm case. The viewer provides a range of interactive tools. Basic navigation options include zoom, window level adjustment, and screenshot capture. After adding annotations, capture a screenshot and save the image to your local system. Let us begin with the basic measurement tools: length, angle, Cobb angle, and bidirectional measurement. To measure a distance, select the length tool and mark 2 points. The measured length is displayed in millimeters. To measure an angle, select 3 points on the image. The calculated angle is displayed in degrees. Next is the Cobb angle tool. Switch to the sagittal view, select the Cobb angle tool, and draw lines along the upper and lower ends. The Cobb angle is calculated automatically to measure the severity of spinal curvature. Next, use the bidirectional measurement tool to measure the length and width of a region simultaneously. The ROI statistics tool allows you to select a region and view its area and corresponding ROI information. Use the freehand ROI tool to manually outline a region. The tool calculates the area of the selected region. The circle and ellipse ROI tools allow you to define a region and view its calculated area values. Additional ROI tools include rectangle and spline. The spline tool is useful for measuring regions with curved boundaries. Next, select the annotation tool. Enter a label, and save it. The annotation can also be repositioned as needed. Next is the probe tool. Select any point on the image to display the Hounsfield unit value for that location. The live wire tool is the automatically follows boundaries based on HU values, helping you outline a region and view its measured area. To remove a markup or annotation, select the required item and use the clear or delete option. Now that we have covered the measurement tools, let us explore other features, starting with window width and window level. Window width and window level can be adjusted manually or by selecting one of the available presets. Open the presets menu and select the required option to quickly apply the appropriate window settings. Next, let us explore the layout options, starting with MPR and 3D MPR. MPR, or multiplanar reconstruction, uses crosshairs to correlate anatomical structures across different imaging planes, making it easier to identify the same location in each view. Load the contrast and non-contrast image series into separate views. Enable Image Slice Sync to scroll through both series simultaneously and compare the corresponding slices side by side. Next is PET Fusion. Split the viewer into two layouts, drag and drop the PET study, and select the Fusion option. Adjust the contrast to visualize the fused PET CT study and compare it with the CT images. You can also modify the color settings as required. The viewer also provides basic navigation tools. Use these options to reset or rotate the study and flip the images as needed. You can flip the image horizontally or use invert to reverse the image intensity for an alternative view of the pathology. Select Reset to restore the original view. The Quick Tools menu provides access to volume rendering, 2D MPR, MIP, minimum and maximum intensity projections, and Cine Play. Cine Play displays image slices as a continuous sequence, which is particularly useful for reviewing ultrasound studies. From the Quick Tools menu, select Volume Rendering to convert the loaded 2D CT scan into a 3D volumetric model. The 3D viewer provides multiple tools, including Crop Box, Bone Scalpel, and Scalpel Line. Let us begin with the Dissection Plane tool. Select the axial dissection plane to scroll through the model axially. Use 3D rotate to reposition the model and examine it from different angles. Similarly, select the coronal dissection plane and use 3D rotate to explore different coronal sections of the model. You can also use the sagittal dissection plane to view cross-sectional anatomy along the sagittal axis. Next, let us explore the crop box tool. The crop box allows you to crop the model from multiple directions and isolate the required region for detailed visualization. Once the required region is selected, disable the crop box to view the cropped 3D model. Next is the scalpel tool. Draw over the required region, then choose to cut inside, cut outside, or cancel the selection. Select Cut Inside to remove the selected portion. Then, use 3D rotate to examine the internal structures from different angles. The bone scalpel works similarly to the scalpel tool but selectively removes bone within the marked region. Select Cut Inside to remove the targeted bone. The bone is now removed from the selected region, allowing the underlying structures to be visualized. The Straight Cut tool provides a free cut option. Position the cutting line, select the required region, and remove it from the model. You can also adjust the volume rendering quality and apply different visual filters to enhance the appearance of the 3D model. The viewer also provides multiple volume rendering presets for visualizing specific anatomical structures. Select the bone preset to isolate and highlight the skeletal structures within the 3D model. Other presets can highlight structures such as the airways by emphasizing air-filled cavities within the scan. Use the airway visualization to examine the highlighted air-filled structures in 3 dimensions. To isolate the lung, use the scalpel tool to select the required region, then choose Cutout to remove the surrounding structures. Additional cleanup can be performed to refine the segmentation and obtain a clearer 3D model of the lung. The 3D viewer also includes measurement and annotation tools for interacting directly with the rendered model. To add an annotation, select a point on the 3D structure, enter the required label, and save it. The annotation remains attached to the model as you interact with it. We now conclude our video here. Thanks for watching our tutorial on DICOM.